Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Tepang Mapotsani. This lesson is brought to you by Northern Cape Department of Education in collaboration with Pagama Research and Development. Now, in today's lesson, we will be focusing on financial mathematics, and the topic is allocated 15 marks plus or minus 3. And the topic for the day is finance growth, decay, and annuities. Now, we'll start with the subtopic of grade 11 revision. Specifically, we'll focus on depreciation. Now, by the end of this lesson, you must be able to revise and use the compound and growth decay formulae. This is a revision that we're going to focus on from grade 11 that we'll need to know in grade 12. Now, the formula that we utilize is A is equals to P, open brackets, plus or minus. The plus or minus will be specific whether it's for a growth or decay. Plus IN, and A is equals to P, open brackets, 1 plus or minus I, all raised to the power N. So those formulas, the first formula, it focuses on a straight line or a simple interest, and the second formula, it focuses on compound. Now, these formulas, we're going to use them to solve problems that includes the problems of a straight line depreciation and the depreciation on reducing balance. This information comes from CAPE document 2011, page 42, and it is also stipulated in our grade 12 ATP 2024, page 5. Remember, this lesson focuses on revision from grade 11. But before you went into grade 11, you were supposed to know the following. You were supposed to be able to use the simple and compound growth formulae, which are as follows. The simple growth formula is A is equals to P into 1 plus IN, close bracket, and the compound growth formula is A is equals to P, open brackets, 1 plus I, close bracket, raised to the power N. We utilize these formulas to solve problems including annual interest, higher purchase, inflation, population growth, and other real-life problems. Now, with regards to these formulas, our focus on grade 10 was as follows. So what was happening is we're dealing with interest in two ways. Remember, interest, as we talk about it, it refers to what? It refers to the amount that you pay or the amount that is charged on the amount that you have received. When I say the amount that you pay, we're talking about a rent on money. It's more like a rent on money, right? So in this case, when we say the rent on money, we're talking about two types of interest, where we have an interest that is on investments and we have the interest that is on loans. Now, the interest on investments is an interest that you receive as you have invested your money. You put your money in the bank and you will get interest for it. That interest, it's more like the rent that the bank will pay for using your own money. The second part of the interest is the interest that we're working on, which is the interest on a loan. The interest on loan, it is charged to you by the bank. This interest, it is the interest that you are supposed to pay back with the loan for having borrowed money from them. So you are actually paying rent for the money that you borrowed from the bank that you are using. So it's more like it's a rent that is due by you to the bank. Now, in grade 10, when we talk about simple and growth formulae, those are two formulas or two methods that we utilize to calculate this interest that is charged on you or that is charged or that you receive from an investment. Now, we'll start with a basic or a baseline activity from grade 10 knowledge to revise the simple and compound interest growth formula. So I will give you 3 minutes to have a revision on number 1 and number 2. Now I'm gonna give you another 3 minutes to complete number 3 and number 4 as our baseline. Right. Welcome back, learners. Now let us discuss the solutions of the activities that we had. Now, on the first question, we are told the following. Sam receives a loan of 28,000 rands for 2 years, and the bank charges 4.7% per annum compound interest. Calculate the amount he must pay back at the end of 2-year period and the interest that he had paid. Now, when you are confronted with this situation, the first thing that you do when you read your statement, you must collect the data. When you are collecting the data, in this case, what are we doing? We are checking what are we given from our statement and which formulas that we must utilize. Now, the first thing that we have is the following. Sam receives a loan of 28,000 rands. So Sam received this money. If we can remember very well from our formula, if we receive the money immediately, it is present. So we call that a present value. So our present value in this question is the amount of 28,000 rands. It is present because we have received the money in the present. Now, we continue with the statement. It says for 2 years. The 2 years there, we refer to it as our period. So N is how much? It is 2. And it says the bank charges 4.7 per annum compound interest. The 4.7 is our rate. Now, in this case, we do not substitute the rate. We rather substitute an I instead. So I is equals to rate over 100. So in this case, to get I from the interest rate that is quoted, we say 4.7 divided by 100. Then that will give us our I. So in this case, our I will be 0.047. Then we proceed. It says per compound interest. So when it says per compound interest, it's already giving us an idea which formulas we're gonna use. So the amount he must pay back. So we notice that it was charged on compound interest. So the formula that we must utilize is the compound growth formula. So we quote down the formula first. We check. The statement says calculate the amount that he must pay back. So the amount that you must pay back, we call it A. It is the future amount that you will pay. You do not pay it present. You pay it in the future at the end of the 2-year period. So you code the formula we're going to use. Then we substitute the variables that are given. So remember, our P was given as 28,000. So in a space of P, we put the 28,000, open bracket 1 plus I. So our I there was 0.047, close bracket, all raised to the power 2. The power 2 there is our period. Now we plug everything in a formula in our calculator. Then we get our answer as 30,693. So that is the future amount that the person has to pay back. Now we must find out how much is the interest. How do we find the interest? So the interest is actually the future amount minus the present. That is to say, it is the amount that you are supposed to pay back minus the amount that you have received. So how much interest did you pay? So remember our future amount from the calculated above, from A, it is 30,693.85. Then we minus the amount that we have received. Then how much interest did we pay? So we paid an interest of 2,963.5. Now, just a quick reminder, you must remember that with grade 10, what we did is an amount is left in a bank or the amount is given to you and the amount is allowed to gain interest. So that is to say, under growth formula, you must understand that our A will always be bigger than P. So that's how growth works. To say you start with a small amount, at the end of the day or in future, you will have to provide a bigger lump sum of the amount. Now let's focus on number 2. Second one, it says now, what amount must Tanisha invest now if she wishes to accumulate 1 million in 10 years time, given that the interest rate is, so here we have two questions. So we are looking at 13% per annum on simple interest. So we are saying, how much does Anisha has to invest right now so that in future he has a certain amount? So what we're saying is, we want to find out what is the present value that Anisha must invest now. Now, remember, Anisha wants to get an amount which is a future amount of 1 million. And she wishes to get this amount in 10 years' time. So our period in this case is how much? It's 10 years. Now let us check on number A. So we're saying for number A, the interest rate is charged at 18% per annum simple interest. So in this case, remember, we must also find I for number A. So to find I there, remember that I, it's always equals to the rate divided by 100. So our rate in this case was 13. So we're going to say 13 divided by 100 to get our I. So our I in this case is 0.13. Right. Remember, on number A, we are saying add simple interest. So in this case, we have to quote the simple interest formula. Remember, and this is an investment, so we're still using the growth formula, which is the simple one. Then we say, okay, we plug in the values that are given to us. We are given that A from the statement was 1 million, and P, it is the unknown. P, it is what we are looking for. Into brackets 1 plus 0.13. So the 0.13 was our I there. So our I was 0.13 multiplied by n, which is the period of 10 years. Then we solve for P in that situation. How do we solve for P? The simpler way to do it is to say, we will take everything on that bracket, we divide by 8 for both sides, then we have P. So when you take everything and divide by 8, you just say P will be 1 million divided by everything that is on inside of the bracket, which is 1 plus 0.13 times 10. So that's how we find our P. So you plug everything in a calculator as it is, then we find that our P is 434,782.61 rands. So that is the amount that Tanisha must invest now if she wishes to accumulate 1 million in 10 years' time using the simple interest. Now let us see number B. So our number B says, now we're saying Tanisha still wants to accumulate 1 million in 10 years' time. But now she checks her options to say, what happens when I actually invest this at a compound interest? Now let us see what happens. So the data is still the same. To say we're still looking for a present value. We still need to know how much Tanisha must invest right now. And we still wish to accumulate the same amount, which is how much? Which is 1 million in 10 years' time. Our interest rate is still the same. It is still 13%. Now the 13% there, remember, we find I from that rate by saying I is equals to the rate, which is the 13 over 100, and you get 0.13 as our I. Now, so because now on number B, we are looking to find an option on compound interest. So we start by saying, all right, we quote the compound interest formula and we substitute the given values. Our A in this case is still 1 million. We still wish to get 1 million. P is the unknown, as it is the amount that I want to invest right now, into 1 plus 0.13 is our I that we got from our rate, close bracket to the power n, and n in this case was 10. Right, we find that P is how much? Is 294,558,34. So remember to find P again. We'll do the same to say we'll take everything that is on the bracket of P and we say that 1 million we divide by 1 plus 0,13 all raised to the power 10. So you plug this as it is in your calculator. It is advisable to take the whole bracket, as when you put everything separate, it can become messy at times, and at times you might even miss a decimal. Remember, I'm putting everything so that you understand that you are not supposed to round off during calculations. We only round off the final answer. Now let's move on. Let's get to number 3. So number 3, it says, how long would it take for an investment of 5,000 to double if the simple interest rate is 11% per annum? So in this case, we follow the standard to say, we read our statement, and on our statement, we must be able to derive our data. Now let's check what is given from our statement. Number 1, how long? It's a question already. So how long? It refers to a period. So we want to find out how long it will take an investment of 5,000 to double. So the investment that I'm making is 5,000. So the amount that I put in the bank as my investment, it's 5,000. So our 5,000 there becomes a present value. 5, 1, 2, 3. Right, to double. So when you're saying to double, we're saying our future amount, we wish to get the present value that I invest today to be multiplied by 2, or to double by 2. When you say double, we know it's multiplication by 2. So our future value will be 5,000 multiplied by 2. So in this case, we'll get our future amount as 10,000. Now we proceed to say, if the simple interest already, they are giving us a clue, which formula are we using, or with which method is this amount invested? So it says the simple interest rate is 11% per annum. So our simple interest rate, we must first quote that interest, the simple interest formula, which is A is equals to P open bracket 1 plus IN. And the rate is 11% per annum. From the rate, so what we do now is we find our I. So our I in this case will be, remember I is a rate over 100. It will be, the rate is 11 over 100. Then our I in this case will be 0,11. Right. Then we proceed. After we put down our formula, we substitute into our formula. Remember our A, it was quoted as 10,000 as we wanted the amount to double. P is 5,000 into 1 plus our I in this case is 0,11 times N multiplied by N, as N is our unknown. Now with this type of a question, first thing that we do here, we are looking for N, and N is inside of the bracket. So when N is inside of the bracket, we start by checking. Anything outside of the bracket must get rid of. If you can check, we have 5,000 there. So to get rid of it, we divide by 5,000 on both sides. In that case, we have 10,000. It's equals to 5, 1, 2, 3 into 1 plus 0,11 N. So in this case, we'll divide by 5,000 both sides. Now, when we divide by the 5,000 both sides, what will remain with, we'll say 10,000, it will be divided by that 5,000, we get 2. It's equal to, on the other side, we'll have 1. So we'll have those that are remaining in the brackets alone. So we'll have 1 plus 0,11 multiplied by N. So it's 0,11 N. So in this case, we solve for the unknown, which is n. Now to get that, we'll transpose the 1 to the other side, or we utilize the additive inverse of the plus there. Right? So when we transpose the 1 to the other side, it will be 2 minus 1. We get 1 on the other side, and we remain with 0,11 n. Then we divide by 0,11 both sides, and we find that our n is 9,09 years. However, remember, it won't take 9,09. Remember, so we need to round off our n to the nearest whole number. When we round it off, it will take approximately 10 years for this investment to do what, to double. Right? Let's move on to the last question. So our last question, let's see. So we are told that Paul invests 35,000 and it accumulates to 55,000 over 2 years. What compound interest rate does Paul need to secure? Again, when we have finance questions, first step, it is always to do what? It is always to derive the data from the statement that is given. Now, number one, check. They said Paul invests. So Paul invests this money currently. So that amount that Paul invests, it becomes a present value. So our present value in this case is 35,000. And it accumulates to. So I put in 35,000, it grows to 55,000. So our 55,000 is the future amount over the period of 10 years. So our N in this case, it will be 10 years. What compound interest rate does Paul need to secure? So in this case, we are looking for the interest rate. But remember, to find the interest rate, in the past solutions that we had, we noticed that to find interest our I, we always say rate over 100. So in this case, we'll start by finding our I, then we'll get the interest rate from the I there. Right. So we check. They said what compound interest? So that statement already give us a clue which formula we must quote or which formula we're going to utilize in this question. Now it says compound interest, so we will quote the compound interest formula and we substitute the variables as given. Our A, which is a future amount, is 55,000. Our P, it is 35,000 there as collected on our data. Open bracket 1 plus I, it remains unknown as we are looking for it, all raised to the power n. Our n in this case, it was 2 years. Now, first thing, divide by 35,000, both sides, as my unknown is inside of the bracket. So we divide by 35,000 to get rid of that 35,000 and remain with what's on the bracket. Now, when we divide by 35,000, we get get the value 1,57 continuous there. I wrote all of it just to remind you that you do not round off when we are within a calculation, right? Thereafter, we notice that we'll remain with this part alone. That has a square on top. Now, to get rid of that square, we must introduce a square root. So we'll introduce the square root. The square root there will get rid of that square for us. And when we introduce the square root, we also introduce it on the other side. So what we do on the left, we also do on the right. Thereafter, when we introduce the square root, we get on our left, we get 1,25356. It equals to 1 plus I, as the square there was solved on the previous step. Thereafter, you solve for I easily there. You can just transpose your 1, transpose the 1 to the other side, then we get our I as 0,25. But remember, we are looking for the interest rate. So we are looking for the rate. We've got our I. Remember when we found I in the previous questions, as we can remember, what we did there, we divided by 100. Now to reverse that process, we divided by the 100. Now we multiply our I by 100. So our I is 0.25. Now, what we do is we take that I of ours, we multiply that I by 100 to get our rate. Now our compound interest rate is 25%. That is to say, in order for Paul to get 55,000 by investing 35,000, Paul will actually need to get an interest rate of 25% compounded. Now, let's focus on today's lesson. Now, our today's lesson, it focuses on the depreciation. Now, from our revision that we had them, we were dealing with growth. Now, depreciation speaks directly to what? It speaks directly to the decay part of it. Now, when we talk about the decay part of it, we're talking about A, it's equals to P into 1 minus I to the power n there for compound, or A, it's equals to P into 1 minus I n for simple decay. So under the depreciation, we notice that our formulae will change the sign to become negative in the middle, right? Depreciation, what is depreciation? Depreciation, we're talking about a loss or decrease of value of an asset over time. So we have assets that loses value. So when they lose value, we are saying they are depreciating in their value, right? So assets like, for example, a vehicle. When you buy a car from a dealership, you know that they will always tell you that the car loses value. In some instances, they will tell you that a car is a liability. Why? Because it will lose value at some point, right? So we talk about those assets that are losing value. Another example, it can be equipment, your office equipment. It will lose value after some time, meaning if I buy it at a certain amount today, if I want to resell it, I will not sell it at the same amount because it will lose some value. So that value that we lose, we call that value depreciation. We have two ways of calculating depreciation. We have a straight line method. The straight line method, it uses the simple or the linear equation, which is the one that I've written down there. So what is a straight line depreciation? It is the depreciation that is calculated as a percentage of the original value P of an asset. That means the straight line depreciation, an object or an asset in this case will do what? It will lose its value with a constant amount. So what we do is the depreciation is calculated on the original value, and yearly the very same asset on the straight line will lose value by that value yearly. So it does not change. It's a straight line. So that means if the depreciation is 5,000, so maybe the vehicle will lose 5,000 this year. Next year, it will also lose the same 5,000. Third year, lose 5,000 continuous, just like that. This is our straight line depreciation. The second method of calculating depreciation is reducing balance depreciation. Now, how does reducing balance work? It is a depreciation that is calculated as a percentage of the previous year's value. The reducing balance uses the formula A. It's equals to P into 1 minus I to the power n. So it uses the compound formula with a negative in the bracket there. So in this case, when we're saying on the previous value, so what are we saying? We are saying in this case, if an asset loses a value by 5,000, it becomes maybe 125,000. That means the next year's depreciation will reduce because it will be calculated on 125,000, maybe not 130. Thereafter, we get the depreciation, maybe it's 3,000. That means for the closing balance for that year will be 122,000. Then the new depreciation again will be calculated on 122,000. So that's what we mean when we're saying on the previous year's value. That means the closing balance of that asset for that year, it will do what? It will calculate the new depreciation yearly. Unlike a straight line where we calculate one depreciation and an object or our asset in this case will lose the value by that amount continuously over the years. So with reducing balance, our depreciation will always be different yearly. Straight line depreciation will be the same. Also, you must know what is a book value. So the book value, it is the value of an asset at any given time after depreciation. So when we say what is the book value of an asset, we are saying maybe after 2 years, how much will this asset worth? So if I buy a car this year, how much will it worth in 2 years' time? That means if I want to sell the car in 2 years' time, how much can I sell it for? So the book value, we are talking about the value of an asset at a specific or at a given time. For example, a vehicle costs 230,000, and in 5 years, the vehicle will cost how much? 120,000. That is to say, I bought the vehicle for 230,000. That's why I'm saying it's my P there. It is a P because I brought it in the present with how much? With 230,000. Now, in 5 years' time, I want to sell the very same vehicle. Now, how much can I sell the vehicle for? I can only sell it for how much? For 120. So what happened there? So the asset has lost value from 130,000 and it went down 120,000. So present, I buy it at 230, then our 120 will become my A. Why does it become the A? Because that's the amount that I'm going to do what? I can sell it for in the future. So that's the amount I can have on this vehicle in future. So if you can see the difference now, with growth, A was always greater than P because I put money right now and that amount will do what? It will grow over years. I invest money, for example, it grows to a certain amount. So the future amount becomes a bit higher. But under depreciation, it's a different scenario. So what happens is my present value is higher than my future amount. That means I use a certain amount of, let's say, to buy that vehicle of 230 right now, but in future, so the future value, it will be how much? 120. It means now my A will be less because it has depreciated. Right. So we move. And what is a scrap value? Very thin line between book value and the scrap value. Now our scrap value is the book value of an asset at the end of its lifespan or at the end of its useful life. This is to say, a scrap value, it differs from book value in this way. A book value, we are talking about this asset being sold to say how much will it be worth in 2 years. But a scrap value would say this is the final amount you can sell the asset for. That means on the scrap value, we are saying the object or the asset does not have value anymore. It cannot be, or it has a certain value. This is the last value that we can sell it for. Right, so let's move on. Let's start with the linear depreciation. Now, linear depreciation is also known as a simple as it uses the simple formula, simple decay or a straight line depreciation. It is calculated on the original amount, meaning year in and year out, our linear depreciation will be calculated from the initial original amount. So if the amount P, our P is 230 like we had in the previous example, we will calculate depreciation once off on the 230,000. So that's what we will have in this case. So when we move on, we must understand that under linear depreciation, it is the same each and every year. So it does not change. So we're saying we calculate it once on the P, then it proceeds in that case to say it remains the same each and every year. To say if you are depreciating by 5,000, even in 2 years' time, we'll depreciate by 5,000 on the remaining balance. The value of an asset decreases to zero over time. So with the linear depreciation, our scrap value in this case, it will equal to zero. That means if a vehicle is sold to you at a straight line depreciation, what you must know is that that vehicle at the end of 5 years or at the end of its useful life, it will be worth zero. It will worth no amount. You can just give it away for free. So this is a straight line depreciation. So under this straight line depreciation, we can see that the graph that we obtain there is a straight line. So that's why it is a straight line depreciation. Why straight line? Because the depreciation is the same throughout. If you can check from zero, if you move from 0 to 2 years, we can check those 2 points there. From that point to that point, it has depreciated from 250 to 200,000. So the depreciation on that point is 50,000. Now, when you proceed, and let's check again between 2 and 4 years, we can see that the difference from here to here, if we can check, is from 200,000 to 150,000. It is still 50,000. So it depreciates by the same amount each and every year. If we can check from 4 to 6 years, you can see in that 2 years again, it will depreciate by another 50,000. As we are moving from 150 to how much? To 100,000. Then over time, it will get to zero. Now at year 10, you can see our graph gets to zero there. That means that's where we have our scrap value. So our scrap value, it is at the end of its useful life. Now any value that we get, let's say at year 6, how much does it worth? It's 100,000. This 100,000 here, at this year, it becomes what we call a book value. As it is the amount, or as it is how much the asset worth after 6 years. So let's move on. Now, how do we find linear depreciation? Our linear depreciation is calculated by the formula A. It's equals to P open bracket 1 minus IN close bracket, where A, it refers to our book value or our scrap value. So this is the final depreciated amount. To say after 5 years, how much does it worth? Or at the end of its lifespan, according to the scrap value, how much does it worth? P is the principal amount. So this is the amount you bought. The principal is the amount you bought an asset for, or how much the asset was worth when you are purchasing it in the present. Our I, it's our depreciation rate per period, and our N, it is the number of periods. Now let's have an example under this one. So let's see. Mavis brought a car for 280,000. The value of the car depreciate at 18% per annum using the straight line method. What will the value of the car be after 3 years? So number one, remember this is still finance. Step number one, collect the data. Collect the information as given from our statement. Number one, Mavis bought a car for 280,000. So I am buying the car in the present. I'm buying the car right now. So the present value of this is 218. 1, 2, 3. So that's how much I buy it. The value of the car depreciate at, so we have our I there. As you can see, it is given as a rate. Remember, to get I, it is always rate over 100. So it still applies from our grade 10. So in this case, we're saying our rate is 18%. We divide that rate by 100 and we get our I as 0.18. Using the straight line method. Using the straight line method, it gives us an idea as to which formula we cut down. So the formula that we cut down for the straight line, it is as follows. A is equals to P into 1 minus IN. What will the value of the car be after 3 years? What will the value of the car be? So after 3 years is the future. So in future, after 3 years, so we're saying our A is a certain amount after 3 years. So N in this case was 3. Now, from the formula that we quoted down, we substitute into the formula to say my P, it's how much? It's 280,000 as I've collected in my data. Open bracket 1 minus my interest rate or my I in this case is 0.18 multiplied by 3. Then you plug everything in the formula as it is. Then you get an A as 128,800. So that is to say, the car that you bought for 280,000, as it depreciate at 18% per annum, it will worth 128,800 on a straight line method after 3 years. So that means after 3 years, I can sell the car for 128,800. So this is my book value after 3 years. Now let's have an activity. So the activity is as follows. I will give you 2 minutes to complete the activity that is given. Right, welcome great works. Now let us discuss the solutions of our activity as it was given to us. Now, so the activity 1, it said the value of a vehicle, it is worth 200,000. It depreciates at 12% per annum. Calculate the value of the vehicle in 5 years' time if the depreciation is calculated using a straight line method. Now, remember finance, step number 1, you always collect the data from the given statement. Now, let's see what is given. They said the value of the vehicle, it is worth, so the value of the vehicle is worth 200,000. Say if I buy the vehicle right now, I'll buy it at 200,000. So I'm buying it right now, the keyword right now. So in the present, so our present is 200,000. It depreciates at 12% per annum. So our I, we are given the rate there. So we convert the rate into I. It's 12%, it's 12 over 100. It's equals to 0.12. It says calculate the value of the vehicle in 5 years' time. So we're looking for the value of vehicle in 5 years. So I buy it at 200,000 right now. So how much will it worth in 5 years? So that means that is the future amount in 5 years. So our future amount in this case, it's what we are looking for. As I want to know how much it will worth in 5 years. Now, N, as it is in 5 years' time, it's given as 5 years, right? They said if the depreciation is calculating using the straight line method. So when you're using the straight line method, number 1, we quote the formula, which is a straight line formula, as it said, A is equals to P open bracket 1 minus I N. Then we substitute values into our formula, which is 200,000. 200,000 there, it represents our P. We open bracket 1 minus I. Our I, as we've calculated there, is 0.12 multiplied by N. Our N in this case was yes. We plug everything in the formula, and this is how much we get as our A. So our future amount is, in this case, is 80,000. So in 5 years' time, the vehicle will worth 80,000. As I have explained earlier on, as we can see, present value in this case is greater than our future value, as we are depreciating, as we are going into the future. So the value is decreasing as we are moving into the future. Now let's look at the second example in this case. Now let us think. Tabo bought a 2 years ago. After 2 years, I think Tabo bought a car 2 years ago. So in this case, a car 2 years ago. After 2 years, the car is worth 230,000. How much did Tabo buy the car for? If it is depreciated at 15% per annum on a straight line method. Now let's see what we're told. So they said after 2 years. So 2 years there, in that case, it's our N. So our N, it's 2. They said after 2 years, the car will worth 230,000. So after 2 years, it's in the future. So our future amount, because the 2 years is in future, it's in 2 years' time, in the future in this case, it's 230,000. They said, how much did Thabo buy the car for? So that means in the present, 2 years ago, how much did I buy it for? So I want to know what was my present value of this vehicle. The depreciation is calculated at the rate of 15% per annum. So the rate is given, so we must convert that rate into I. So we'll have our rate, which is 15 divided by 100, so which is 0.15. That is our I. On a straight line method, this gives us a clue which formula to utilize. So in this case, we have to use the straight line or the simple or the linear depreciation formula, which is A is equal to P into 1 minus IN. We substitute the values that are given. So we have A. So our A in future, in that 2 years time, A, it was given as 230,000. P is the amount that I want to know, the present value. 1 minus our I is 0.15 times 2. The 2 there is N. Now you simplify and you solve for P. Remember, like we did in the revision, we divide both sides by everything that is in the bracket. We divide it on this side and we divided the 230,000 with everything that is on the bracket to get the value of P. What I mean is our P, it's equals to 230,000. We divide it by everything in the bracket, it's 1 minus 0.15 multiplied by 2. Then we get our present value as 328,571.43. Now, that's our present value. That is to say, after or 2 years ago, Thabo bought the car for 228,571.43. Now, let's move on to the second activity. So I'll give you 2 minutes to work on this activity. Right, welcome, grade 12s. Let us see what was given as our problem. They said a school equipment is worth 30,000 after 4 years it was bought. How much did it cost to purchase the equipment if the depreciation is calculated at 13% on a straight line method? So now we are saying in this case, collect the data. Let us see what does the statement give us. It says a school equipment is worth 30,000 after 4 years. That means already after 4 years, we have in the future. The future amount in this case is 30,000 after 4 years. 4 years there, it becomes my N. It was bought. How much did it cost to purchase the equipment? So in the present, that means 4 years ago, how much did I purchase this equipment for? So that means my present value, it's what I'm looking for. If the depreciation is calculated at 13% on a straight line method. So our depreciation in this case, we have the rate. We are given the rate. So remember, we convert the rate into I. So it's going to be 13 divided by 100. So which is 0.13. So that's our I. On a straight line method. So now we quote the formula that we need to utilize as it says our straight line. We plug in the values. We know our A as we have given from our data, 30,000. Put 30,000 in a space of P. It's P. We're looking for it. 1 minus in a space of I. We have 0.13 multiplied by 4, which is our N. We get P. So that is a mistake. That's not A. It's our P. So we get P as 62,500. That means you bought the equipment for 62,500, 4 years ago. Then after 4 years, it was worth how much? 30,000. Now let's talk about reducing balance depreciation. We have dealt with the linear balance, or with the linear. Now, reducing balance depreciation, it is calculated on the previous year's value. That is to say, the closing amount on the previous year will be used to calculate the new depreciation for this year. That means each and every year we will have a new depreciation. Given that the value will decrease yearly, that means the depreciation will also decrease every year. So that means maybe 1 year gonna be the depreciation of 5,000. In second year, it will be the depreciation of 3,000, for example. Then on the third year, it will be 2,000. The other year, 1,000, and so forth. That means the depreciation will always reduce, or it will always decrease in that case, as it is calculated on the closing balance of the last year's value. Oh, yes. Hence, the depreciation decreases. So the value of the depreciation decreases as the assets lose value. With reducing balance, the asset always retains some value. That is to say, when we are using the reducing balance depreciation, our asset, it will not get to the scrap value of the, so the scrap value is not equals to 0. So it's not equals to 0 at the end of its lifespan. So at the end of its lifespan, using reducing balance, the asset will always have a certain value. Now in this case, we're saying this one, it will use an exponential graph. As you can see, from year 0 to year 2, we can say it depreciated from 120 to 60,000. So that is a difference of 60,000 there. And we check from year 2 to year 4. How much did you go from? We went from 60,000 and we went to, let's say, 25,000. So in that case, you can see that it is not the same as the 60,000 that we initially had. So in this case, it was maybe a drop of 35,000. So the new depreciation on this one was 35,000. Here it was 60,000. So it is not the same, unlike the linear depreciation. And as you can see, our scrap value, which is the end of the useful life, it is not going straight to 0. It ends at 20,000. So it retains some value at the end of its lifespan. Now, how do we calculate the reducing balance? We calculate by the formula A, it's equals to P open bracket 1 minus I all raised to the power n. It's raised to the power n, as you also get an exponential graph in this case. So it raised to a certain exponent, hence exponential graph. Where A, it is still a book value or the scrap value. Scrap value, remember, if it's at the end of the lifespan, book value, any value, or the value of the asset at any period. So A is our final depreciated amount. P is our principal amount, which is the original amount. I is the rate of depreciation, and N is the number of periods. So the repetition there is just to show you the graph clearly, as I was showing you on the previous slide. Right, so let's just proceed. Now, let's look at the example. The example says, Zayat buys equipment worth 80,000 for his business. He plans to sell the equipment at a depreciated value after using it for 5 years. The depreciation is calculated at 20% per annum on reducing balance. What can he sell the equipment for after 5 years? Number 1, finance. We always collect the data. We check. Zayat buys an equipment worth 80,000. So we are buying it now in the present. So it is worth how much? 80,000. So present value in this case, it's 80,000. As we are buying it in the present. He plans to sell the equipment at a depreciated value after using it for 5 years. So in that case, our N is equals to 5. The depreciation is calculated at a rate of 20%. It's a rate as it is given as a percentage. So we convert that into a into I. So our I, remember, is rate over 100. So it's 20 divided by 100, which is 0.2. In this case, on a reducing balance, what can he sell the equipment for after 5 years? So 5 years, it's in the future. So we're looking for the future value of this equipment after 5 years. Now we check. We quote the formula. How do we quote the formula? It's always given in the clue using the reducing balance. So the statement will give us which method it is calculated on. So we quote that formula. Then we substitute into the values our P. So in the space of A will remain A because it is unknown. So what I'm looking for, P. In the space of P, we put how much? 80,000. As we quoted, it is 80,000 into 1 minus 0.2, all raised to the power 5. Now we plug everything in the formula. We get our A as 26,214.4. That is to say, after 5 years, this equipment can be sold for 26,214.4. Now let us have an activity quick. Activity number 3. I'll give you another 2 minutes to just work on this activity. Right, welcome back, Retros. Let's see how far, or let's see how the question was. The question says, the equipment worth 40,000 depreciate at the rate of 16%, at 16% per annum. What will the equipment worth in 5 years' time if the depreciation is calculated on reducing balance? Remember, we're collecting the data from the statement. Number 1, equipment is worth 40,000. So this is how much the equipment is worth right now when I go into the store. So my present value, it's 40,000. It depreciates at 16% per annum. That is my rate. So we convert the rate into I. So our I will be 16 divided by 100. It will be 0.16. What will the equipment worth in 4 years' time? So in 4 years' time, it's in future. So in this case, we are looking for our future value. So worth in 4 years' time. So our future value, so the period is 4 years, and in 4 years' time, it's 4. If the depreciation is calculated on a reducing balance, so that gives us a clue to say, this is the formula that you must utilize. It's a reducing balance formula. We quote it down. We substitute the given values. In the space of A, we remain with A because A is my unknown. It's what I'm looking for. Where there is P, we put 40,000 into 1 minus our rate. It was 16%, so we convert that into I as 0.16. We put it there on the space of I. Close bracket, our n to the power n. So in the space of that n is 4. Plug everything in our formula, and we get our value of A as 19,914.85. So that is how much the equipment will worth after 4 years. So it will have lost value from 40,000. It went down to 19,000. So it has depreciated in this case. Right. Now let's have another example. Let's see. So what is the cost price of a vehicle worth 300,000 after 4 years of being used? The depreciation is calculated at 15% per annum on a reducing balance. Now let's get the data from the statement. What does the statement tell us? It says, what is the cost price of a vehicle that is worth? So the vehicle is worth 300,000 after 4 years of being used. So we've used this vehicle for 4 years. After 4 years, it is now 400. So it is now 300,000. That means in future, after that 4 years, it's 300,000. So N, it's already given because we're saying after 4 years. And they said our depreciation is calculated on 15%. So our I It's how much? It's 15. We take the rate, we divide it by 100. So 0.15 on a reducing balance method. So they said, what is the cost price? So the cost price is the amount that I could have bought that I bought the vehicle for 4 years ago. So that was the present value 4 years ago. It was a certain amount. So they said we're calculating it on a reducing balance method. So on a reducing balance method, we quote the method as A is equals to P into 1 minus I all raised to the power N. After that, we plug in the formula. So we're saying we're given our A as 300,000. In a space of A, I substitute 300,000 equals to, in a space of P, I just put P as I'm looking for the P. Then into 1 minus 0.15 all raised to the power 4. 0.15 is our I in that case. N, in a space of N, we put 4. Yes. Then we solve for P in that case. We know we divide by what is in the bracket, both sides. Then what we get? We get P as 574,705.76. So in this case, we are saying this cost price of the vehicle was 574,705.76, right? So this is activity number 4. So it's activity number 4. So I'll give you a 2 minutes to complete this activity. Right, welcome back, Beetles. Now let us look at the solutions to this activity. Now we are told that the office is worth 50,000 after it has been used for 6 years. How much did the equipment cost if the equipment depreciates at 12% per annum on a reducing balance? So they said it has been used for 6 years already. So after it has been used for 6 years, it was worth 50,000. So 6 years. So in future, the future amount then it's 15,000. And our N is 6. How much did the equipment cost? So we're saying, how much did it cost 6 years ago before it was used? So we're looking for the present value 6 years ago. If the equipment depreciates, we are given the rate of depreciation. We are converting that into our I. We get the rate, which is rate over 100, which is 12 divided by 100, which is 0.12 on a reducing balance method. So that we know which formula to quote down. It is the compound, which is A is equal to P into 1 minus I all raised to the power N. We substitute into the formula. In a space of A, we given A as 50,000. So we put 50,000 where A is. It's equals to, in the space of P, we remain with P as the unknown, as we are looking for the value of P, we do not know it, into 1 minus our I, which is 0.12, as we've calculated I there, all raised to the power N. So our N in this case, in the space of N, we put 6 years. Then how much is the P? So the present value was 107,664.85. So the present value, or the equipment costed 107,664.86 rands 6 years before it was used, or when it was bought. Now let's have an activity. So for this activity, this side, I'll give you 4 minutes to complete this activity. All right, welcome back, Turtles. Now let's just give you the continued vision of activity 5. So hopefully you are done with number 1 and number 2. Now this is number 3 and number 4. So you are given also 4 minutes to complete number 3 and number 4. we had that homework. We'll mark it on the next lesson, grade 12. So welcome. Let's deal with the summary. So the summary in this lesson, we have learned or we have calculated using the linear depreciation. And we found out that linear depreciation is calculated as a percentage of the original value P. And we are using the formula A for the linear depreciation. It's equals to P into 1 minus IN. And we know that the depreciation that we found, it is the same each and every year. And the scrap value of the equipment or our asset will equal to 0 at the end of its lifespan. That is what a linear depreciation. And our reducing balance depreciation, in this case, it is calculated as a percentage also on the previous year's value. In this case, we're saying depreciation is calculated on the closing balance of that asset yearly. That is to say, the cost price of the book value of the asset at the end of each year, it becomes our value that we utilize to calculate the depreciation. We're using the compound formula, which is A, it's equals to P into 1 minus IN, I close bracket O to the power N. We know that, or we have learned that on the reducing balance depreciation, the depreciation amount of an asset, it decreases. That is to say, it is not the same each and every year, it decreases. So 1 year it can be a certain amount, the next year it will decrease, the other year it will also decrease. So the value or the asset loses value with a different value yearly, and that value is decreasing. The scrap value is not equals to 0. That means at the end of its lifespan, you won't sell the equipment at the scrap value of 0. So it will always have a certain amount at the end. So next lesson, it will focus on financial mathematics part 2. It is still the revision that we're having from grade 11. We will still revise and use the simple and compound and growth decay formulae. A is equals to P into 1 plus minus IN, and A is equals to P into 1 plus minus I all raised to the power N. And we will solve problems including the effect of different compound growth and decay, including nominal and effective interest rates. This is the end of our lesson. Have a great day. Thank you so much.